Mr. Trump, Michael Wolff is here. You have 45 minutes. And his whole face, something happens to his face, and it's like somebody has startled him with the most extraordinary piece of information. and he says, 45 minutes? You don't give Michael Wolff 45 minutes. Do you know who this is? And then he launches into this thing, which I've now heard he launches in for everyone. He's the biggest, the greatest, the most incredible, the most, I was sold. And in fact, he said, okay, well, I'm going to do the show, and then you're going to come back to my house in Beverly Hills with me, which was interesting because no one in the whole country knew Trump had a house in Beverly Hills. It's a huge house right on the corner of Sunset and Rodeo. You know, kind of another $30 million bucks. Yeah. But I went back there and he said, you know, would you like anything? And I remember he opened the refrigerator, and the refrigerator is filled with pints of Haagen-Dazs ice cream. That's all that's there. row. And then he took one out, and I said, no, I'm okay. But he gave me one anyway. So
because he doesn't listen.
And so we went into this in this living room, which is kind of filled with sort of cast-off hotel lobby furniture, and we sat on these overstuffed things, and we ate from the tubs of ice cream for several hours, and it was a lot of ice cream. I mean, he didn't stop really. I mean, it's 3 tubs at least. Then I wrote this piece, and it was. I certainly would not have said that it was flattering in any way. This is the piece. This was 2 weeks before the Brexit vote. And I said, well, what's your feeling about Brexit? And he said, what? I said, Brexit? Huh. And I said, you know, the vote in the UK to leave the European Union? Oh, yeah, I'm for that. He said.
That level of sophisticated argument is currently going on now. So he's sort of...
So anyway, the piece came out, and then I got and it was the cover story, and there was a kind of interesting illustration photograph of him, and I got a note from him after the piece came out, and it said, "Cool cover." So I thought, I guess he liked that. I don't know.
So he wouldn't have read the. He wouldn't have read the.
No, he didn't read it. He just saw it.
Saw the cover. But you clearly got access after the election once he was in.
Totally, and then it was. So I was sort of. So during the transition itself. So after he's elected, I was in Trump Tower. I saw him. Congratulate.
This next unit is a coffee can amplifier, and I don't know from which cable operator this was, but in the early days, some cable operators saved money. Cable operators were always very thrifty since they were building infrastructure out of cash flow. So every dollar not spent was available to be used to expand the plant and get more customers. And this is a very basic unit. And it's hard not to think that it may have some tubes inside. It's got a transistor, at least for its power supply. The connectors are N connectors, which were used in precision radio applications. They were rarely used in cable. But whoever built this next device is a Gerald Model T1000 Balun, and then had one F connector, maybe as a test point. This next object is a Gerald preamplifier, and it was used to boost the level of off-air signals, which could be very, very weak. Often you were picking up channels, off-air channels from cities that were scores, even 100 or more miles away, with a big antenna array on top of a tower or on top of a mountaintop. So you had very weak signals. You had to boost their level. And this unit was a two-channel unit. It looks like channel 10 and channel 12 that would have been used in either a cable head end or possibly in an MATV system head end for off-air signals.
And it's, as Jim mentioned, it's got two-channel capability. Each one of the little horizontal modules in the upper part of the chassis are dedicated to one particular channel. And like some of the other equipment that we've seen, this uses the older C-type connectors instead of the newer F-type connectors. So an antenna would be connected to the input connector on the right-hand side of the chassis that's seen here. Going in the opposite direction, the amplifier that we see here, this gold-colored housing, is a C-Core 1 gigahertz amplifier, and this could be considered pretty close to state-of-the-art. The cable industry has for a number of years operated its networks or has built extensions to its existing plants using 1 gigahertz technology. If we look at that from a channel capacity perspective, at least from the perspective of counting the number of channels that were carried on the network, this 1 gigahertz amplifier. The device we see in this particular picture is a Kaiser cable amplifier. It looks like a line extender type amplifier. In the early tree and branch all coax distribution networks that were used by the cable industry up through the late 1980s and into the early 1990s, the cable network itself that was distributing signals from the head end throughout the community used two main parts. One was the trunk cable network, which typically used larger diameter cables on the order of 3/4 of an inch diameter or so, and they used bigger trunk amplifiers that were spaced every 1,500 feet to 2,000 feet.
The next item is a sweep frequency generator, and this was a piece of gear that was in the shop back at the cable company's office, and it was used to align. Could be used, as I mentioned, to align channel processors, but it also could be used to test
the device in the picture here is a Gerald 704 field strength meter. This was a very, very important tool for engineers and technicians and even installers in cable networks. This particular one is a vacuum tube field strength meter, and it's used to measure the signal strength or the RF signal power of the channels carried on the cable network. So this particular device was a big improvement over some of the homebrew varieties of devices used to measure signal strength. And so a device like the old 704 here, made by Gerald, which got its start back in the 1950s and was sold to the cable industry through the 1960s.
The next unit is a Qube box. Qube was a very futuristic cable service, launched initially in Columbus, Ohio, and then in Cincinnati and Pittsburgh and a few other places. And Qube was an interactive television system. This is a wired remote control for a Qube set-top box. Qube was a two-way service, and it offered a variety of channels. Again, not a lot of satellite services. This was mid to late 70s, I believe. This was Warner's big push into cable, and they were trying to bring additional value. Down at the bottom there, there are a variety of additional buttons that could be used for voting and for quiz shows, and they would send signals back upstream through the cable system if all was well, and allow people to participate in programming. And it was used, it's hard to say it was a hugely compelling service for consumers, but city councils loved it. And Warner would go to town and do a big dog and pony show explaining why they should get the franchise for a city, and they would show the service. They would fly the city council to Columbus to see it working. Columbus had a lot of its own programming, but that's where things like Nickelodeon were originated, was by Warner in Columbus for the Qube service. So this was an important step for cable. It was not a home run in terms of commercial success. In fact, it was so expensive to install that eventually it got largely dropped. TCI bought the Pittsburgh system and tore all the Qube stuff out and put in regular cable technology. But Time Warner did inherit, I think, Columbus and Cincinnati, and we had huge warehouses full of these set-top boxes. They weren't very reliable, so we kept repairing them. And it was, again, an enormous expense, but it was part of doing business in those cities. And this is back when urban cable wasn't very profitable and rural cable was. This is one of the reasons why urban cable wasn't profitable.
The Pioneer model BT1350 is a remote control for the Qube system, and like some of the other remote control devices available to subscribers back in the day, this is a wired remote control. The Qube technology that was deployed in a number of markets, while incredibly expensive to operate, provided the cable industry with a vast amount of experience in operating two-way cable networks and gauging the behavior of subscribers and on all kinds of things. One thing I recall was that the Qube set top or some variation of it had a tamper switch that could be used to detect if customers were trying to pop the set top open to see what was going on inside of the thing. And it's my understanding that apparently a fair percentage or a surprising percentage of customers were in fact trying to open these things up to see what was going on. But the whole Qube project really provided the cable industry with an extensive amount of knowledge and experience about advanced technologies and interactivity, two-way operation of networks, and a lot of what we know today in the operation of cable networks got its foundation or had its foundation in the Qube system.
That said, operating two-way through all coaxial cable systems with many amplifiers in series really didn't work very well, and so it was useful for franchising, and it was useful for pay-per-view to some extent, but until the advent of fiber technologies that really shortened the amount of coaxial cable you had, two-way was not great technology and was viewed by some operators with a great deal of skepticism. The next unit is a Tocom 55 Plus, so a 55-channel set-top box, maybe more, maybe plus. But I think its main characteristic is it has a wireless remote control. This was a big step forward. Also another big source of service calls, but something that customers really liked, and was certainly something that that was destined to be a big deal. This unit almost surely was two-way. Tocom was a pioneer in two-way services. Tocom pioneered home security using two-way cable plant, which was, again, not a success, but a good learning experience. The next unit is a Qube box. Qube was a very futuristic cable service launched initially in Columbus, Ohio. And
could support the carriage of 150 channels simultaneously. Of course, these days, many cable operators have moved away from the old analog TV channels to mostly or all digital operation, which gives the equivalent of hundreds and hundreds of channels. But this is a 1 gigahertz amplifier, and the next image shows what this looks like on the inside. The RWT 1-Balun transformer functionally is the same as the previous Balun in that this provides the transition between an unbalanced coaxial cable and a balanced 300 ohm transmission line on the back of the TV set going to the tuner inside the TV set. And it also provides an impedance transformation between the 75 ohm impedance of the coaxial cable and the 300 ohm impedance of the twin lead wire going from the back of the TV set to the tuner.
And also, obviously, has taken advantage of mass production and commoditization of materials for the operator. These things, probably cost less than $1.
I think they were probably more on the order of a quarter, but there were some variations of these that were optimized for use on the back of an FM radio. Many cable companies carried FM radio services on the network in addition to TV channels. And the Manhattan Cable Oak Gamut 26 converter is kind of a next step up from that. This particular one tunes not only the 12 channels, that is 12 channels 2 through 13, but also channels that typical TV sets were incapable of tuning, channels in what was called the midband, or what still is called the midband, and to some extent the superband. And you'll note that the channels on the right side of the left-hand dial have letter designations. And the VHF channels were numbered, channel 2 through 13. But the midband channels started at channel A-2, then A-1, although I don't think this one covers the A-2 and A-1 channels. And then channel A, channel B, C, D, E, F, G, H, and I. And then after that was channel 7. Then after channel 13 came channel J, K, L, M, N, and so on. Well, over time, standardization got in the way and actually assigned channel numbers to these channels, but this is a little bit more advanced set-top box or converter box that tunes some of these channels in the midband and part of the superband.
This was a huge step forward for cable, because this ushered in an era when cable began to have access to a lot of additional programming and began to have value in urban markets. Things like Home Box Office and Ted Turner Superstation and so forth required more and more channel capacity. And again, the TV sets couldn't tune these additional channels. And so the operators had to provide set-top boxes. A huge capital expense and a huge source of operating expense, because they were very sophisticated devices, but weren't very reliable. And they were made to be, cheap. So a lot of money was spent sending trucks out to retrieve defective boxes and replace them. But it was nevertheless an important, opened an important doorway in terms of business.
The Manhattan Cable Oak Gamut 26 converter is kind of a The Motorola Cyber Surfer Roadrunner cable modem is another example of a DOCSIS cable modem, and in comparison to the early Land City cable modem, which was about the size of a desktop computer, this is fairly small, doesn't take up much space. Different manufacturers produce different versions of cable modems for use in subscribers' homes, and relatively low-cost devices from the perspective of the cable company buying these in very, very large quantities. But this particular example has the Roadrunner name on it, which let Jim elaborate upon that.
Well, Roadrunner was the brand that Time Warner Cable used to launch its cable modem service. Some of the other multiple system operators went together and launched something called At Home, which was a very clever brand. But it was a VC-funded company, and it eventually dawned on these cable operators that they were giving up part of an extremely lucrative business to this VC-funded public company. So that business model didn't work. Roadrunner was just a brand, and it happened that we also, through Warner Brothers, owned the Roadrunner figure. And so that was, until recently, the brand that was used for all Time Warner cable modem customers.
The Motorola Cyber Surfer Roadrunner cable modem is another example of the Pioneer BC1000 is a lower cost and we'll call it lower performance set-top box that enabled reception of the standard lineup of channels, and by flipping a little switch to the premium position on the right-hand side, it allowed the subscriber to receive the pay service that the cable company provided. The Pioneer BC1000 is a lower cost and we'll call it lower performance set-top box that enabled Land City cable modem. As you look at this, it's very apparent that this is about the size of a desktop computer. It's a first-generation cable modem that the cable industry used. Thankfully, I think for most subscribers, the cable modems of today are much, much smaller. But this is one of the very first models of cable modem that the cable industry provided to its subscribers. Now, interestingly, the Land City, along with a couple other vendors, used proprietary technology for operation. What that means is that if a cable operator bought the cable modems from Land City and the head-end equipment from Land City, they had to continue to use products from Land City. The same was true of the Zenith cable modems and I believe the Motorola cable modems of the day that were proprietary in nature. And it was in the about the 1996 time frame that a group of cable operators and cable television laboratories got together and started the development of a specification to standardize cable modem technology, and that resulted in the release in the late 1990s of what we call DOCSIS, or Data Over Cable Service Interface Specifications, and the first version of that came out in the late 1990s, and already today we're up to version 3.1 of DOCSIS, which has meant that we've had continued improvements since the late 1990s in the ability to provide higher and higher data speeds to and from our customers, but at the same time do so in a box much, much smaller than the one in this particular picture.
Land City was notable. Not only was it very early into cable modems, but it also, that company chose to contribute its patents behind this cable modem on a royalty-free basis to the DOCSIS process. So the roots of DOCSIS really were in this cable modem, unlike competitors like Motorola and Zenith and Toshiba and some others who were not willing to do that. This really got the ball rolling for DOCSIS, and that was this whole commoditization phenomenon where cable modems went from costing $1,000 or more for this unit down to $20 or $30, where they eventually got as DOCSIS was produced in volume, shrunk into silicon, and sold in a very competitive market.
Land City cable modem. As you look at this, it's very apparent that this is about the size of a desktop computer. It's a first-generation cable modem that the cable industry used. Thankfully, I think for most subscribers, the cable modems of today are much, much smaller. But this is one of the very first models of cable modem that
This next item is a very early set-top box, and it's a 12-channel converter, has a 12-channel tuner on it. And you might well ask why you would have a 12-channel converter since TV sets already could tune the 12 VHF channels. And the answer was direct pickup. As cable began to get into more urban markets, the local transmitters were strong. In places like Manhattan, they were very strong indeed off the Empire State Building. So Manhattan Cable, among others, began to buy these converters, which were well shielded, could tune a channel from the cable, and then provide an output channel on channel 3 or 4 that was not used for off-air signals, and thereby get rid of the problem where off-air channels would leak directly into TV sets and create ghosting and interference. So it was a big, expensive step, but for urban cable, this was a necessity. This next item is a very early set-top box.
The Gerald Starcom 36 STB is another example of a remote control capable converter box. This particular one has the remote control that's sitting on top of the converter box itself. So the converter box, which can just barely be seen in the lower part of the photo, would be sitting probably on top of the TV set, and then the remote control at the easy chair or the couch or the end table. But here it's tethered to the box with a wire. Unlike the handheld remote controls that most people are familiar with these days, it was a wired remote control. Had a lot of mechanical issues, certainly a good way to allow consumers to tune through channels from the convenience of the couch or the lazy boy, but with the inconvenience of these things occasionally failing and having to be replaced by the cable company, because while they provided a pretty useful way to tune channels, these weren't the most reliable devices that we provided to our customers back in those days.
But this unit probably still predates the distribution of programming over satellites to cable head ends. All the channels are either look like local off-airs. They've got a time and weather channel and a program guide and News Oklahoma. There's something called Z, and I'm willing to bet that that was a pay TV channel. But operators were, outside of one or two movie channels, they really didn't have a lot to sell, and that really slowed down the adoption of cable in urban markets. And that's the thing that changed once cable got satellite distribution of programming.
The Gerald Starcom 36S The Dolphin two-way splitter is a very, very typical example of the splitters used at the subscriber premises for many, many years. It was a stamped sheet metal design with a pressed-in backing plate that unfortunately let water in too easily and let the RF signals that were in there out. These were not real well-shielded devices, but it's a very, very simple, basic RF power splitter. It can't pass the 30 or 60 volts or 90 volts of electricity used to power amplifiers, which is why these small devices were used on the sides of homes. Functionally, they're the same as the splitters that are used today, although today's splitters have been really optimized for much better RF performance over a much wider frequency range. They have better RF shielding performance. They're designed to operate in the presence of stronger signals from cable modems that can generate something called passive device intermodulation, which is another discussion all in itself. But very, very simple example of a typical two-way drop splitter.
In some ways, it also represents cable's increasing sophistication in terms of commoditizing its vendors and the materials that it used. Devices like this were made offshore, made very, very inexpensively in large quantities. And of course, cable has never stopped trying to commoditize its vendors and gets better at it every year. All the vendors seem to survive anyhow. Make it up in volume, I guess.
The Dolphin.
The next picture is a Craftsman line splitter. And Craftsman is a brand that's long gone, although I have a feeling it morphed into Magnavox or some such. But this is a splitter to split a piece of rigid aluminum cable into two cables to go down two streets or two different routes. It's got a clamp on top that would clamp it to the messenger cable that held up the coax. And then these were compression connectors, not too different than from plumbing connectors, that would squeeze down gently on the jacket of the aluminum cable and provide continuity. Inside this was some circuitry which, first of all, allowed the power to pass through to both legs, because downstream of this you might well have amplifiers. So you'd pass your 30 volts or 60 volts through the splitter. But you would divide off the radio signals, and they would go through a little transformer, a little passive transformer circuit with a couple of little toroids with little wires wrapped around them by Chinese ladies, wherever they were made. And that would split the power so that half went down one side and half went down the other. So you lost power as you went, or you lost radio power as
The first object that we're looking at is the Able Cable statue. This one is dated June of 1969. Some of you may recall the Ready Kilowatt electrical power industry, and Able Cable is the cable industry's version of Ready Kilowatt, used as kind of a marketing piece for the cable industry.
Although cable marketing usually meant taking orders as people chased your trucks down the street because they wanted TV reception. But Ready Kilowatt was a cute little mascot. Of course, that was back when an all-electric home was a good thing. I don't think we've seen a lot of that in recent decades. But Able Cable was a way to try to brand cable and give it some personality. I'm not sure that cable really...
The matching transformer might have an FM
transformer. This is a trip back in time to but it's a strange beast. TV set. TV set.
And here you can see with the lid open, the amplifier circuit, it's a fairly compact boost up the signals. It has signals from hybrid
broadband amplifiers. It actually had a Icetron.
The OGAF LRC, the device in the picture here is a Gerald 704 field strength meter.
The next unit is a Qube device. Qube was a very futuristic cable service.
The Manhattan Cable Oak Docks gamut cable modem and in comparison to the early and standard lineup of channels, and by flipping the little switch to the premium position on the right hand side, it allows you subscribers to receive different case versions of cable modems for use in subscribers' homes in Land City cable modem. As you look at this, it's very apparent that this is about the size of a desktop computer.
It's a 12-channel converter.
STB is another example of a remote control capable converter box. This particular one.
Next, we're seeing a piece of CommScope coax taking orders as people chased your trucks down the street because they wanted TV reception.
What we see here is a little cylindrical trap from a company called Eagle Comtronics, which is...
This next device is
this particular device is a pressure tap. The two-way splitter is a very, very typical.
I'm Diane Crispin, Senior Vice President of Programs and Development here at the Cable Center, and I am joined today by Paul Maxwell, Jim Chittix, Ron Rannick, and we're coming to you from the Barco Library at the Cable Center. And today we're going to talk about our new virtual reality exhibit that will be kicking off shortly. And Paul's going to give some context, and the rest of the panel will provide some stories and some perspective about why it's important that we capture this information.
Good. Thanks, Diane. As she said, I'm Paul Maxwell. I've been around the industry for a little while and chronicled a lot of it. And these two guys sitting here figured in a hell of a lot of what I wrote about and what Ron wrote about at Communications Technology and other places. Jim Chittix was with Time Warner Cable for quite some time. He helped create the modern business. Ron Rannick, now at Cisco, was with quite a few people down the line. These guys helped put together what became.
I'm done.
In order to get this optimized
of course, that was back when all electric home was good for
flexible drop cable out from the end.
lines. Devices like this would have been made offshore, made very, very inexpensive.
Now, subscriber drop cable coaxial channels, hundreds of frequency portable antenna but it was all solid state.
Nevertheless,
Started the development of a specification to standardize that.
Really short two-way.